Okay, so hello, my name's Henry, and I'm going to talk today a little bit about the interview process for a prospective mathematics student at the University of Cambridge. I'll tell you a little bit about my own experiences when I was trying to become a student at Cambridge, as well as how maybe you should go about preparing for such a thing, although it's hard to say, and maybe what you should hopefully expect going into the interview. And maybe at the end we'll do a question or two just as an exercise. So I did my interview personally about 9 years ago now, and I interviewed at Trinity College in Cambridge. And okay, the first thing I need to tell you when it comes to trying to prepare for this interview is that it really varies a lot depending on which college you're trying to get into. It's actually quite some different procedure depending on which college you want to do. And what I did at Trinity might be completely different from what you're expected to do, depending on what your college is that you're trying to get into. So I'd really recommend the first thing you should do if you want to prepare properly for this is you really need to go to your specific college and look on their website or try to find out exactly what the specific procedure is for your college, because it can really vary. For Trinity, I had to do kind of a short test beforehand and then an in-person interview about the questions on that test afterwards. So somehow this means that they can put slightly harder questions on the test. You can have a go at them, maybe make some progress, maybe don't. The real point is that somehow you have something to discuss in the interview afterwards, and then you'll talk about going into more depth on these questions. This is, as far as I understand, not universal amongst other colleges. Like you might be expected simply to answer the questions on the spot there in your interview, which is a bit more stressful, but maybe the questions will be a bit easier then so that you can actually, they have to take into account the fact that you're going to be a bit stressed during the interview. So hopefully the questions are normally quite doable, and they really don't want to give you impossible questions in the interview at least. And they just want to see how you think through things, basically. So as I say, the main point of these interviews, or at least the cliche is that they want to see how you work, how your brain works, how you think about mathematics, and to prove that you really have that capability of thinking of things in a kind of exploratory way. And so that it should feel kind of like a discussion between you and them. So if you get stuck, don't feel like you should. The worst thing you can do is to go blank and to not say anything. The best thing you can do is to kind of give some kind of ideas or throw out some random suggestions if you're not exactly sure what to do, and then hopefully they will kind of nudge you in the correct direction. But at the same time, of course, you shouldn't just hurry into saying any old chaos. You should make sure that that you are trying to come up with correct mathematics, and that you're, if you are a little bit unsure, then throwing out ideas is one thing, but you should still try and make some, once they want you to actually answer the question, you should make some steps towards actually doing so. Okay, so now I'll give you a bit of my experience. One of the most important things I learned from my interviews specifically is don't be afraid to say, I don't know something, or I haven't learned that yet. Because, the biggest mistake I made in my interview was that they asked me some question, and my weakness was always in the more physics, mechanics style things. And they asked me some question. One of these questions on this test was to do with some oscillations or something to do with physics. And I hadn't actually learned it at school yet, but I wasn't 100% sure if I had learned it at school yet or not. And they asked me, and I said, yeah, I think I learned this. And then we spent like 10 minutes on this question that I had no idea what was going on. And it was kind of a disaster. So my first suggestion should be, if they ask you something like, have you learned this at school? Only say yes if it's for sure the case. So for instance, if you're a case similar to me, you're more comfortable in one area, such as pure mathematics, don't be afraid to try and lean them in that direction, because especially if you're more comfortable with pure, I feel like they definitely have a strong bias towards pure mathematics. And if you go on to take the STEP exam later, you'll also see that this is the case. If you're more interested in mechanics, it's a bit more difficult, but you should still try and nudge somehow to show, to make it clear, and maybe in your personal statement it will also be the case, to make it clear what your strengths, what your interests really are. Hopefully you should try and nudge them to be talking about those kind of things, so you can show off what you're really interested in about mathematics, and how you go about solving a problem in an area that you are comfortable in. Okay, so now I'll try and go into some ideas of what you should be doing to actually prepare for this interview. It's very hard to say because each college, as I've already said, has very different procedures on this. And also, a lot of them don't really give much information, I'm sorry to say, about what you should be expecting in the interview. But somehow you can get some idea, at least, of the kind of questions they're going to ask and how the process of the interview, at least, itself will go. Okay, so the first thing that every one of these websites, every college says is that to prepare, you should know all of your material from AS level, from year 12, very, very well. And obviously I suggest this as well. Your first stepping stone, if you want to go to a top university to study mathematics, to know all of the material from secondary school, like the back of your hand. I mean, it should be incredibly clear. And then the point of these interviews is to kind of take extra steps towards being more creative with this material you already know. So for instance, probability, statistics, anything to do with basic calculus, differentiation, integration, you should know these things really well because they're going to expect you to know these things. And if you know them really well, then firstly, it will be clear in the interview that you know them really well, but also you won't have to spend time thinking, remembering certain things. You'll just be able to go straight into trying to solve the problem that they've given you. Okay, so in terms of resources that you can actually use to prepare for your interview, as I've said, it's kind of hard to find them. One is this TBO problem solving booklet. So this is some collection of problems that are meant to, or supposedly meant to help you during your admissions process and during the interview, questions that you might get, kind of questions, the style of question that you might get in an interview. Now, there are many questions here. You can spend hours working on all of these, and I think that's probably good practice just to get your head in the right mind frame of trying to work through more creative problems that you might get in school. But at the same time, this really does focus on some very specific style of questions that you might get in an interview. Like there are a lot of what's known as combinatorics, counting problems in here, as well as probability, this kind of thing. And you should be expecting to get lots of questions like this in the interview, but also other questions I think you should be expecting which don't appear on here. Things that you're more expected to see at school. This is really just, this document is more an emphasis on questions that might be unusual to you if you've only done school maths. So for instance, graphing, I think this is a question that you'll often get in an interview setting. Here's some weird function. You don't really know what it is. You haven't seen it before. It's made of some functions that you're familiar with, exponentials, logarithms, this kind of thing. And then the question is just draw a graph of this function. This is something I got in my interview. This is something that seems to be very often appearing in these interviews. And so you should be very comfortable with differentiation, finding stationary points of functions and this kind of thing, and having a good idea of working out how a function changes at certain points. Calculating the stationary points is one thing, but you also need to know how the function will look away from the stationary points, obviously. So this is kind of an intuitive thing that I think if you work a lot on these kind of questions, I guess if you look on the internet, you can find these kind of things. You should be able to get some practice in. So on the same note, a second resource that I think is useful, especially if you're really preparing to go the whole way and do the STEP exam at the end of the year, is the STEP support program. Now, you don't need to worry too much about this yet, although maybe it is useful to look at these things. But there is these foundation modules on this website that are kind of meant to be a slow progression towards really getting to the point where you can do Step 2 and Step 3, which are the exams you have to pass to get into Cambridge. And somehow some of these foundation modules are aimed at Year 12 students or people who've finished Year 12. And this can be some kind of preparation towards what you might expect in an interview. Now, these questions are obviously way harder than what you should expect in an interview, but at the same time, you can get some idea of maybe, like I say, if you want to work more on calculus, which doesn't really appear in this problem-solving booklet, this can be a resource where you can practice your calculus skills. And always bearing in mind that the actual question you're going to get in your interview should be way, way easier, hopefully. Okay, and then a third resource I found, which is useful, especially if you're applying to Trinity, is actually on the Trinity website, they have sample tests for what I mentioned earlier in this video, where I got a test. If you go into Trinity, this is what you're going to have to do to get in. You're going to have to do a little test first and then the interview afterwards. They have some specimen tests. Now, it's only, I think, 3 of them, and they're quite... it won't take you too long to do all of them if you're really focused on these things. But it really gives you an idea of, what genre of question you should be expecting. Like, we have some kind of combinatorics questions, something with graphing, as I say, or maybe this isn't with graphing, but with some kind of geometry in the plane, some more calculus, something with, some kind of probability / combinatorics question, again, some kind of probability / combinatorics question. This is something that really is, this problem solving booklet is very useful because this kind of question is very big in these interviews. Then, there will normally be some kind of mechanics questions as well. And then again, more combinatorics, more mechanics, and then some kind of analysis kind of thing. These, even if the questions here are all quite specific, the genre of question you should keep in mind. Like this kind of question, like this tennis tournament question 1, this kind of thing is I think they like to ask this kind of question. Okay, and in terms of actually practicing how you should perform in an interview rather than just practicing your mathematics, I think there are a couple of things that you can do. One is to really practice when you're working through, say, some of these questions, if you feel like doing that, to really not just writing down an answer, but really speaking while you're doing it, really like going into detail, like thinking through your thought process, being really clear about what you actually want to do to get to the solution here. This is something that maybe in school mathematics is not really a focus, but being 100% clear about every thought process you have. In these interviews, you really can't be too clear. You're not going to bore them. Just go into as much detail as possible, even if it seems stupid, because they will appreciate that. And they will think to themselves, this is university mathematics, because university mathematics is about being as clear as possible in all of your arguments. And if you understand this will be a subtle hint to them that you're already thinking in the right direction. Okay, so now, as promised, I'm going to do one of these interview questions. We're going to go through some kind of, what I might imagine the interview might go as. So I chose this first question from this Trinity sample test that I showed you, specifically because I think this question is quite hard, and also it's kind of a good interview question in that with some nudging, you can slowly get closer and closer towards the correct answer. Really the method towards getting the correct answer. And, okay, one thing that is true about these Trinity tests, if you really go through them, if you choose to, is that the difficulty of the questions varies quite wildly depending on which question you choose. So this first question, I think, is one of the hardest on the test, but like other questions, like question 4 and 5, for instance, on this same test that I showed you, I think are quite easy. But this won't save you just doing the easy questions, unfortunately, because if you do the easy questions in this test and then ace them, they will simply ask you in the interview about different questions, such as this one. So fortunately, you just need to be on your best game when the interview comes along. Okay, so what is this question? This question is kind of a typical kind of combinatoric style question. You have some situation and you're just counting loads of numbers. But unfortunately, here we have an n. So we can't just count on our fingers. We have to do some actual clever mathematics. So my first intuition, or my first guess when I see an n, is that, okay, we're probably going to have to use some kind of induction. When I see this question, so okay, well, what is the question? We have a tennis tournament, the first round of a tennis tournament, and we have an even number of players, luckily, and we're just trying to work out how many different possible pairings there are. Obviously, a tennis game has 2 players, and how many different possible pairings there are if we're going to calculate in the first round of this tennis tournament. And of course, the first thing to note is that if I pair A and B together, this is the same as pairing B and A together in a game. So there's going to be some. It's not just 2n factorial. It's more complicated than this. Okay, so first, I look at this question and, okay, let's just draw a little picture. So we have all these different games. So we have n games, and we have to try and put these players into these boxes. But obviously, it's more difficult than if there was just 2n boxes, because if I switch this first box around, for instance, it's the same game. So I've counted something twice if I try and do it like this. So, the kind of answer we should expect is something like 2n factorial divided by some stuff, and you'll see from the answer, which is 2n minus 1 factorial over 2 to the n minus 1 times n minus 1 factorial, you'll see that it looks something like this. Like we've taken 2n factorial and then quotient it out by some stuff. So as I said, my first guess is induction. And I look at this and I think for a bit, and I basically have no idea what to do. I have no clue. It seems quite tough. Like, you think of some tactics, like, okay, I can choose the first game and then the rest, but then there's some overlap of things that can happen. And so, okay, firstly, and I think if you get a question like this in an interview, the best thing to do is to take up time and to maybe give yourself some ideas to just put in small numbers for n, see if you can calculate and see if it holds. I mean, if we're going to end up doing an induction, as you know, you need to do this anyway in the end. So let's just try n equals 1 and n equals 2 and see maybe if we can find some method that appears by doing this. So for n equals 1, okay, this is easy, right? I mean, we only have one possible game, right? And you can check that this value over here, this 2n minus 1 factorial thing, does in fact equal 1 here. This is an easy calculation using the 0 factorial is equal to 1. So, okay, n equals 2 is a bit more interesting. So, okay, so now we have two boxes. And the first thing to note, the first thing to observe is that if you've already determined who are the two players in the first game, then the second game is completely determined, right? You know who the two players in this game are. So the only thing we need to consider is how to sort the number of possibilities for the first game. And this is something that we'll see in the higher values for n as well. So, okay, if I just fix some person, one of my 4 players, and I put them here, then all I need to calculate is how many different opponents this person can have, actually. And of course, the answer is 3. There are 3 other players. 3 other players can go in here. Right, so there's 3 choices here, and then the second game is completely determined from this. So we know the value is 3. And again, you can check with this expression that it is indeed equal to 3. Okay, so we see some kind of tactic here. Fixing a player, just some person, and then seeing what players they play against, and then the rest of it kind of being determined already, or maybe being inductively determined. So let's try n equals 3 now. Okay, so now we have 3 boxes. And okay, I think that there are probably, one of the reasons I think this is a nice question is because there's probably some other solutions to the one that I come up with. So we fixed one player in the previous value. We fixed some person. We just say this is a special person we're choosing for our calculation, and then we do all the calculation around them. Here, let's fix 2 people. So we fixed 2 people. One person here and one person here. Now, okay, I can't be sure that they're in different games. So there's 2 possibilities. So I fix these 2 people. One possibility is that they play each other. Right, so this would be then that the 2 people are in the first box together. And then the rest, as you'll see, is now, wait a second, this is just the n equals 2 case, right? This is now we have 4 players, 2 boxes. So then we know this number is 3. And okay, already in our mind we're thinking, okay, induction is coming into play here. Or okay, they don't play each other. And then, okay, then we're in this first picture, right, where we have one person in the first, one person in the second, and then the last game is still blank. And as we know, once more, the first 2 games, if we know what's happened in the first 2 games, who is playing in the first 2 games, the third game is completely determined. There's 2 players left, they must be thrown into the third game. So here we can see that the number of choices from here is, okay, we have 4 players left to choose, 4 people to choose to go here, and then if the remaining 3 people to choose to go here. So 3 times 4 is 12. And then we simply sum these 2 together to get 15. And you can check again that this is equal. So now we have some kind of strategy here. So again, as I said, looking at this question, I had no idea what to do. I had no ideas. I mean, had some ideas that maybe you could say like, okay, maybe I can think of this and this and this. But hopefully in an interview setting, they would nudge you towards thinking of looking in, some kind of idea that you can use. Because a lot of ideas you'll come up with this for this question, I think, are going to be wrong or aren't going to work because of some kind of it being difficult to quotient out the different possibilities that can overlap with each other in different situations. So somehow this is the kind of question that you should expect in an interview. One that at first seems completely hard to penetrate, but later you kind of slowly get more understanding by thinking about things, and just suddenly some kind of technique suddenly appears. So now let's see for an arbitrary n. So we've done our base cases of our induction. So if we want to do induction, we now can. So okay, again, I'm going to fix 2 players. Right, so 2 people. And again, we have these 2 possibilities. So these 2, we have 2 possibilities. Either they play each other, by our inductive hypothesis, again, you should try and argue as clearly as possible when you're trying to explain your solution to one of these questions. By our inductive hypothesis, we know that the number of possibilities in this situation is this, where I put an n minus 1 instead of an n, right? So this should be 2n minus 3 factorial over 2 to the n minus 2, n minus 2 factorial. Okay? And then the other possibilities, they don't play each other. And now, okay, we can look at what we did here. Here we have a choice of 2n minus 2 people, right? Here we have a choice of 2n minus 3 people after we've chosen that first person. And then here we have the same situation as here, but now with n minus 2. So again, we apply our inductive hypothesis, and we know this should be 2n minus 5 factorial over 2 to the n minus 3, n minus 3 factorial. Right? This is the value of the number of possible pairings when we have n minus 2 games to work with. And then we just sum these together. And then hopefully we should get the correct answer. Let's see. Okay, so this plus this. Okay, and then we can factorize some things out, of course. We have a 2n minus 3, and we have a 2n minus 5 factorial that we can take out, as well as 2 to the n minus 2, n minus 2 factorial. So already that's some of the factors in the expression we're trying to get at the end. And then here we should have a 2n minus 4. Here we should have 2n minus 2 multiplied by 2 multiplied by n minus 2. So these are the bits that come from the denominator here. Right? And then again, we can do some more factorizing. We can now take out 2n minus 4. So now this becomes 2n minus 3 factorial. We've taken out a 2n minus 4. And what do we have left? We have 1 plus 2n minus 2, which looks very close to the answer. 2n minus 3 factorial over 2 to the n minus 2, n minus 2 factorial times 2n minus 1. And okay, this looks close, but not quite there, right? We needed a 2n minus 1 factorial on the top, and we needed 2 to the n minus 1 and n minus 1 factorial on the bottom. But you'll notice that I can just add in 2n minus 2 on the top and the bottom, because obviously these two things are equal, and then we've got exactly our expression. Okay, so a harder question than you might get in your interview, I think, but one that really displays the kind of thing that they might be wanting from you. Something that's kind of hard at first, and then you play around a bit, you put in some values of n, and you slowly get closer and closer towards finding a method, and then you test out your method, and it turns out to work exactly as you wanted. Okay, so thank you so much for listening. If you have any further questions, please feel free to reach out, and maybe we can give you some kind of better ideas of things that we went through or that you might be expecting in your interview. Okay, thanks.